Hello students and welcome back. So now we are going to design a 3 to 8 decoder using the 2 to 4 decoders. So in this video we are going to talk about that how can we design a decoder with enable signal. We'll talk about the working principle of 3 to 8 decoder and how to design it using 2 to 4 decoders. So let us get started. So decoder with enable, we are going to put one additional input signal and that is called enable. Now what is this signal going to do? Enable will always be at the highest priority, and if enable is 0, then all the outputs of the decoder are set to be 0. That means the circuit is disabled. And when we put enable equal to 1, then the decoder is going to work normally. That means based on the value of input A and B, it will decide one of the output Y0, Y2, Y3, any one which we have. So now how do we design that? Well, nothing very complex. We have the block diagram where now we have three inputs. A, B were already there, and then we have enable. When we look at the truth table, look at the first entry very carefully. This is not a single entry. This is basically 4 different entries. 0 is for E, and for B and A, X is written. That means whatever is the value of A and B. There are 4 possible cases: 0, 0, 0, 1, 1, 0, 1, 1. In all these cases, all the 4 output variables are 0. And when E is equal to 1, then again we have 4 cases, and there we are having the normal functionality of a decoder which we have already studied. So now let us come to the designing of a 3 to 8 decoder. So here we have the block diagram. I am going to have one enable on the 3 to 8. That is optional if you want it, or you can skip it. Let us keep it. And then I have A, B, C. These are my 3 inputs, and Y0, 1 to Y7. These are the 8 outputs. So now the question is, how do we connect different 2 to 4 decoders to make one 3 to 8 decoder? In one 3 to 8 decoder I have 8 outputs. In a 2 to 4 decoder I have 4 outputs. That means something is very clear, that I need minimum 2 decoders. So here I take first decoder which will give me the output Y0 to Y3, and another decoder which will give me the output Y4 to Y7. Now I have another problem, that these decoders have only 2 inputs, whereas I have 3 inputs, A, B, C. So then what we do, we take one more decoder. The priority of my inputs are A is the least and C is the most significant bit. So the most significant bit is going to control everything. So on the leftmost decoder, which is the highest priority decoder, I connect C. So it is connected with 0. Now 0 and C can be 0 and C can be 1. When I keep the combination 0, 0, in this decoder the first output will be 1. And what I have done, I have connected that output to the enable of first output decoder. That means now that decoder is active, and based on the value of A and B, one of the output of Y0 to Y3 will be 1. When I keep C equal to 1, 0, 1 is selected. So the second output of this decoder is high. So the lower output decoder is active, and based on the value of A and B, Y4 to Y7, one of the output will be generated. So that is how it is going to work. Now we are going to code it in Vivado. So first of all, I have my 2 to 4 decoder. I have written a new code. I am not using the old one because I have extra input E. Otherwise it is same D0, D1. These are my two inputs, Y0, Y1, Y2, Y3, 4 outputs. And the logic is exactly the same. Earlier we were writing Y0 as D1 bar and D0 bar, D1 bar D0, D1 D0 bar and D1 D0. Only addition is in every term we are adding enable signal also. So E and is added in all the assignments. So this is our 2 to 4 decoder. Now we are coming to 3 to 8 decoder. So here I am having three inputs A, B, C. C is the highest priority, A is the lowest priority. Then we have these 8 outputs Y0 to Y7 and I have one more input which is enable. So that is what we have, and then we declare two wires P and Q. Now the module instantiation is interesting. First of all, I take my 2 to 4 decoder. I instantiate it. Now I need to remember the order. The order was enable D0 D1 and then Y0 Y1 Y2 Y3. So in D0 and D1 the lower priority is going to come first. So C is lower and the other one was connected to 0, right? Let us just revise that. So here you can see the combination is 0 and C. C is on the lower side and 0 is on the higher side. Okay. And then Y0 is connected to one wire which I will call P. Y1 is connected to another wire, we can call it Q. Y2 and Y3 are not connected at all. So here also Y0 I connect with P, Y1 I connect with Q, and I don't mention anything for Y2 and Y3. Now coming to the output side, the enable signal for the first one is P, then the inputs are A and B and outputs are Y0 to Y3. For the second decoder, enable signal is Q, inputs are same A and B and outputs are Y4 to Y7. So this is how we code using module instantiation. Now we are going to check the schematic. In the schematic we can clearly see enable is connected to the enable of first decoder and C and 0 are the lines here. For this decoder the enable signal is coming from Y0 and for this one the enable is coming from Y1. There are no connection for Y2 and Y3 and they are going to Z, high impedance. A and B, these are the inputs for both of them, and Y0 to Y3 and Y4 to Y7, these are the outputs that we have. Let us cross check the functionality as well. So here we can observe when the enable is 1 in all the cases, when the input is 0 0 0, Y0 is 1. When we have 0 0 1, Y1, then Y2, then Y3, Y4, Y5, Y6 and Y7 for 1 1 1. And again when we have 0 0 0, so Y0 is 1. So this is how we have efficiently designed a 3 to 8 decoder using 2 to 4 decoder. So students, now the opposite of decoder is encoder, and we are going to talk about a little interesting encoder in our next video, and that is priority encoder. So keep learning. Thank you.